Hello viewers, we are still on partial differentiation, and then we've been given a question that if z is equal to lean into exponent x plus exponent y, we are asked to show that partial derivative of z over partial derivative of x plus partial derivative of z over partial derivative of y equal to 1 with respect to this question. So looking at the question, you know that it is function of a function, and so we are going to treat it as a function of a function, and then to solve it we use chain rule of partial differentiation. So in doing this, we say we can call this equation 1. So we say from equation 1, let u equal to exponent x plus exponent y. Please permit me to put it in brackets. And so that if u is equal to exponent x plus exponent y, it means that our z from equation 1 will now be ln u. Okay, ln u. So we can call this equation 2, and we call this, okay, this is ln u. We can call this equation 3. Okay, so having done that, what this implies is for us to solve this question, we have to find the partial derivative of z with respect to x and that of z with respect to y. We add them and see if it is going to give us 1. Okay, so since we are done with that, we can say that from equation 2, differentiate partially u with respect to x. So from equation 2, partial derivative of u with respect to x will give us exponent x. That is, if we differentiate this u with respect to x, it's going to give us exponent x. Note, in this one we are not going to consider we are not going to keep consider this x raised to exponent x exponent y, because it is not multiplied by exponent x. So if we are differentiating u partially with respect to x, we are going to have exponent x. Similarly, if we are differentiating u partially with respect to y, we are going to have exponent y. Okay, that is for equation 2. Then from equation 3, if we differentiate z with respect to u from equation 3, we differentiate z partially with respect to u. If we differentiate the u, it will give us 1 over u. We differentiate the u, we are going to have 1 over u. So since we've gotten these parameters down, we have to pick this first, partial derivative of z with respect to x, and we have an answer. We also pick solve for partial derivative of z with respect to y, we have an answer, and then we add to see if it is going to give us 1. So to do partial derivative of z with respect to x will be equal to, we make use of this, partial derivative of u with respect to x times, this is the chain rule now. Okay, let me say applying chain rule. Let me say applying chain rule to find partial derivative of z with respect to x. So this is going to give us partial derivative of u with respect to x times partial this with respect to this, and this with respect to this, times partial derivative of z with respect to u. Because I said in the other videos that when you cancel out this, it will still give you what is in the left hand side. So this will be equal to partial derivative of u with respect to x is exponent x. So we have exponent x times partial derivative of z with respect to u is 1 over u. So this is the same thing as saying that a partial derivative of z all over that of x is equal to, if we say exponent x times 1 over u, we are going to have exponent x over u. But our u from our mathematical statement was equal to exponent x plus exponent y. So we say but u equal to exponent x plus exponent y. So if we have this, this will be exponent x all over our u is exponent x plus exponent y. So the partial derivative of z with respect to x is exponent x plus exponent y. We can call this our equation 4. So since we have done with it, this we have to also find the partial derivative of z with respect to y. So applying same chain rule, the same chain rule. So we have, let's say to determine partial derivative of z with respect to y. So we are still going to apply the same chain rule. So this over this. So we are going to consider partial derivative of u with respect to y multiplied by partial derivative of z with respect to u. So we have partial derivative of u with respect to y times partial derivative of z with respect to u. Like I said, if you cancel out this, you're still going to have this. So partial derivative of u with respect to y is exponent y times partial derivative of z with respect to u is 1 over u. So this will be equal to, if you say this times this, you are going to have exponent y all over u. Okay, let's move to this side of the board. Let's move to this side of the board. If we move to this side of the board, we are going to have that our partial derivative of z with respect to y equal to exponent. Okay, but from here, let's say but u equal to exponent x plus exponent y. So if we bring the value here, we are going to have that a partial derivative of z with respect to y will be exponent y all over exponent x plus exponent y. We can call this our equation 5. So since we've been able to determine this, which is what we have in our equation 4, and we've been able to determine this, which is what we have in our equation 5, we have to add the 2. We have to add the 2 so that we find out if actually it will be equal to 1. So we now say we take the left hand side, this is the left hand side. So the left hand side is partial derivative of z with respect to x plus partial derivative of z with respect to y equal to. Now, what is partial derivative of z? It is what? Exponent. Okay, partial derivative of z with respect to x is exponent x over exponent x plus exponent y plus. Now, partial derivative of z with respect to y is this exponent y all over exponent x plus exponent y. Now this is addition. Okay, so let's continue our solution to find out if it is going to give us 1. So we continue. So we now have that we take the left hand side, partial derivative of z with respect to x plus that of z with respect to y will be equal to. Now, if we take the LCM of this and this, if we take, this is plus. So if we take the LCM of this and this, it's going to give us the same thing. So taking the LCM, so okay, I can say taking the LCM of the right hand side of the equation, taking the LCM of the right hand side of the equation, or let me call this equation 6. So I say taking LCM of the right hand side of equation 6. So when we do that, we are going to have this partial derivative of z with respect to x plus partial derivative of z with respect to y equal to, if we take the LCM of this, the right hand side, which is this, it's going to give us exponent x plus exponent y. And then we are going to, so I haven't taken the LCM. This is the LCM because they are the same, so the LCM will be the same value. So if at this point we say this goes into this will be 1. If you multiply it by this, it will give you the same thing. This going into this LCM will be 1. Multiplied by exponent x will give you exponent x plus. This other side going into this will be 1. Multiplied by exponent y will give you exponent y. So if you have that, you can decide to put it in brackets. So this would be partial derivative of z with that of x plus that of y will be equal to, we cancel out here, this is 1 and this is 1, so this will give us 1 over 1. So we have the partial derivative of z all over x plus that of z for y equal to 1 divided by 1 is 1. So we have been able to prove that given this question, that given that z equal to ln into exponent x plus exponent y, we've been able to prove that the partial derivative of z with respect to x plus the partial derivative of z with respect to y would equal to 1. So we've been able to prove this. So basically that is how to solve that question. Thank you.